Right, this is some help on line integral for some people. It will be mostly, well, it is all more than one variable, so it's just multivariable line integrals. Right, first off we've got the definition. I hope you can see that. This is the integral of c, where c is like a curve or a part of a curve, and we've got the function here, and this is the same as the integral from alpha to beta. Now we get alpha and beta from the curve here, so I'll talk more about that in a bit, of the function with the parameterization of c, which is what c actually is, you know, like the function, dotted with the differentiation of the parameterization of c dt. Right, if that made no sense, then don't worry, I've got some examples later to make sense of it all. So, and we've also got some nice little facts here, which is the integral of minus c of f is minus the integral of c of f, and the integral of c1 plus c2, two different curves added together, of f is the integral of c1 f plus c2f. Yep. Right. And you may also get in a question that a line integral is known as the work done. Now, to explain the method, I'm going to do it by pointing. I'm not going to have too much writing down because it's more an explanation. So you'll get given a parameterization, which I've got an example here of t times t squared, and p differentiation of that is 1 and 2t. Agreed? Yes, because we need the p, and then we also need the p dash of t. We'll have some examples for you to make sense of. And here we've got here alpha a, b, and c are just scalars, and x and y are the variables, and this is our integral that we're going to be working with. So of ax by dx plus cx dy. Now what you do is you get these parts from here. So this is our x and y, think of it as, and this is our dx and dy, because we've differentiated. So we put all the x's in, so where there's an x we put a t, where there's a y we put a t squared. So put all that in there, and for our dx we put a 1, and our dy we put a 2t, and then we put that as dt on the end, and then you integrate it, and you integrate it between the points which will be given sometimes in the question, but most of the time it's between 0 and 1. Yep. Next. More stuff. Right, now if you're not given the parameterization of c, say you're given, you want to find the line integral between the points x0, y0, z0 and x1, y1, z1, then we just use this simple formula here. So this is going to be a parameterization of t1, t2, t3, which will just be like x, y, z. t1 is 1 minus t times x0 plus t times x1, and it's the same for the y and z, as you can see, and this will give you a parameterization. And for circles, we just have, you lay it out as x squared plus y squared equals r squared, which is the radius, and for our parameterization we have p of t, well this is our x and this is our y, so where it says t1 you'd put that, t2 you'd put that. I should have laid that out a bit better, but and the r will be replaced by the radius which is in the question, hopefully. And then again you just differentiate it and you'll get, let's have a look, r minus r sine t and r cosine t. Yeah, and I've got a circle example coming up as well to help you make sense of that. Right, now here's our example. Find the line integral of the integral of c x squared dx plus y dy plus xz minus y dz, where c is the straight line from 0, 0, 0 to 1, 2, 4. Right, now like I said before, we're going to have to work out our parameterization of c using our formula we had back there. So we've got our x0, y0, z0 and x1, y1, z1. So we'll just use these functions here, and if you put that in, you will get our parameterization of t, 2t and 4t. We differentiate, we get 1, 2, 4. Now, like I said, it's simple as just plugging it all in, the x, the y, the z, and you'll be left. Remember, we put the dx is 1, dy is 2, dz is 4, so times by 1, 2, and 4, and we've got dt on the end of everything. We can simplify this further, and this is between 0 and 1, because any function, I should have said back here, once you've done this, you integrate it between 0 and 1. Yep, and I think we can simplify that further to get this, which is the integral from 0 to 1 of 17t squared minus 40 dt. Integrate that, simple as, and you'll get the answer 11 over 2, and that is your line integral. Simple as. Circle example. Oh, why are they all popping up? Find the line integral of integral of x squared dx plus y dy, where c is the upper half of the circle of radius 3, with centre minus 2, 3, from 1, 3 to minus 5, 3. Now here is especially important, because here we're actually going from 1, 3 to minus 5, 3, so it's going to be a negative line integral, so you're allowed to get negative ones. And we have a shifted centre, just ignore these. Now, like I said before, we have x, which is this is our parameterization. We have x is r cosine t. Now, because we have a shifted center, we subtract 2, yeah, and we add 3 to the y, and then we differentiate. We get this minus 3 sine t, 3 cosine t. Again, we put everything into here, so they put the x in there and square all this. And we put the y in and leave that as it is. Put the dy in and the dx in. And this will give you this. As you can see, that should all make sense. And we've got a dt at the end. We simplify this further. I did this on Maple because it's quite messy. I suggest you find some other program to simplify it for you. La-di-da-di-da. Minus 27 cosine t squared sine t plus 45 sine t cosine t minus 12 sine t plus 9 cosine t dt. And then once you've integrated that, I used the computer program to do that, I got 9 cosine t cubed plus 45 over 2 sine t squared plus 12 cosine t plus 9 sine t between 0 and pi. Now, if you're wondering why it's between 0 and pi, it's because of our circle. It asks here for the upper half of the circle, and if we start here, this is the upper half, so we go from 0 to pi. If it asked for, say, the right side of the triangle, then we'd have from minus pi over 2 to pi over 2, yeah? And similarly, if it asked for from the other direction, here we've gone from 1 to minus 5, we could go the other way around and we go from pi to 0. Yeah, and once you put these values in, so all that pi minus the 0 stuff, then you'll get the answer minus 42, which is a negative line integral, which is, well, it looks right to us because we're going in a negative direction. And that's the end.